Hello everyone, in this video I'm going to be talking about repolarization and depolarization and the dipole model. So in this first picture we have a cell at rest and we have a surface electrode on the cell. We can describe the voltage seen at the electrode by integrating the charge on the cell. So we have positive at both sides of the electrode, so we're not going to have any voltage difference. As depolarization occurs or the wavefront moves across the cell, we'll start to get negatives on the left side here. So we'll have a slight deflection. As the wavefront continues to move across the cell, we'll have half positive, half negative, so we'll have max deflection. Then as it continues to move across and we have more negatives, the difference between the positive and negative electrodes start to decrease, so the voltage decreases. Then we have the cell that has been completely depolarized. From this wavefront, we can see that depolarization causes the voltage measurement to come to some peak and then drop off. So we have a positive facing waveform on the surface of the cell. And then we can talk about repolarization. And so this starts from the same condition that we just left off at. So there's negatives on both sides of the electrode, so we have no potential difference. As repolarization begins to occur, we start having positives on the left-hand side, which will have a negative deflection. And then as we're halfway done with repolarization, we'll be integrating the max number of negative relative to the max number positive, and we've reached our peak voltage, but negative. As repolarization continues, meaning we'll have more positive, we'll be integrating fewer and fewer negative charges at the electrode, so the voltage starts to drop off. Then we'll be back to where we started initially, which was rest. So from this from this graph, you can see that repolarization has a negative facing waveform. In my previous video, I talked about how a dipole can represent the depolarization wavefront. I also talked about the ECG waveform. Now we're going to talk about why the P wave and the T wave are both positive when the P wave is depolarization and the T wave is repolarization. So like I just said, the dipole model represents the depolarization wavefront. So if we have, if we're looking at lead 2, the negative electrode is at the right arm and the positive electrode is at the left leg. So we have, in this first picture, representing the P wave, we have depolarization going down. Then we have depolarization going up. Then we have depolarization going down. So this is positive because it's going down. And then negative because it's going up. Positive because it's going down. Then we have depolarization up again, and it's negative, just like it was before. Then we have depolarization down, so it's positive again. So these are both, so the P wave and T wave are both going down, and they're both positive if we're talking about depolarization. If we want to talk about repolarization, the arrow would have to be going the other way. But we're talking about depolarization here instead. So if we're going from the negative electrode at the right arm and the positive electrode at the left leg instead. Thanks for watching.